Hey, welcome. We're on task 5.3, and we're going to go through the flowchart and we're going to look at the justifications for this flowchart. Like, there's a lot of arrows and whatnot, and we want to make sure that from a geometry perspective that we can show why it results in what it results in here. So, the first one I want to look at is right here. If you have an equilateral ABC, well, then you have three congruent sides, and you can see that is based on the definition of an equilateral triangle. It has three congruent sides. Another one we have is this idea that over here, that CE is a line of reflection. Well, if you have an equilateral triangle and you fold it along the edge here, okay, that creates a line of reflection, and the mathematical justification for that is that equilateral triangles can be folded onto themselves about a line of reflection. It's part of the definition. What else do we have? We have, if it's a line of reflection, we have the idea that it's perpendicular. CD is perpendicular to AB. We also have the idea that D is a midpoint, okay? And the reason for that goes back to the definition of a reflection, okay? Because it is a reflection, then when you fold it, it'll be at a perpendicular, the fold will be to that edge where you fold it. And since you fold it, it means that these two are going to be congruent. What else do we have? Well, we know that AD is congruent to DB, given that D is the midpoint, and that goes back to the idea of the definition of a midpoint splits a segment into two congruent sides. We also have this one, which is, it just says that CD is congruent to itself, and that is, let's see, where is it here? Yeah, 17, okay. That one is this one right here. It's called the reflexive property. And we do that because sometimes we want to show that triangles are congruent. Maybe we need to do side angle side or side side side, and they share the same side. Well, we have to say from a geometry perspective that it's congruent to itself, so we can do side angle side or side side side. Now, given these three things, we were able to talk about the triangles ACD. So triangle ACD, which was this, being congruent to BCD. And what we were able to say, go back to this, to say that these are congruent was because of the side angle side that we talked about. So that goes back to side angle, oops, wrong one here. That's the side angle side criteria. If two triangles have corresponding side angle side congruent, then the triangles are congruent. Then there's some others. Well, given that the triangles are congruent, then we can say that a corresponding pair of angles is congruent. So this one, the rationale, is probably the most important one that you'll learn. It's corresponding parts of congruent triangles must be congruent. And then, now that we've laid these cases out, we've got definition of altitude, definition of median, definition of angle bisector, and definition of perpendicular bisectors. Here they are, because we met the definition for each of these.